This video is about the conversions that we have worked on in class. So we are working for moles. So first of all, we got to give a definition of moles. Then we got to make sure we understand what is the unit for grams, or I should say what unit grams is it's referring to, and then the number of molecules. So all those quantities have to be specifically defined, okay? So let's start with moles first. So moles, okay, it's nothing but a number, okay, moles. So it's just a number, okay? And this number, okay, is equal to 6.022 times 10 to the 23rd, okay? And this is the number of items, okay, that is contained in one mole. For example, when we talk about dozen, okay, we know that this means 12 items, okay? When we say deca, for example, right, we know that we are talking about 10 items, okay? When we say hexa, like for the hexagon, okay, we know that this is 6 items, okay? So for example, in the case of hexagon, okay, then we know that this is a shape with 6 sides, right? So we still use the word hexa, okay, but then we have gon, okay, so hexagon, which means, so this one goes there, which means a polygon, okay, with 6 sides. Deca, same thing. If we say decagon, okay, is a polygon with 10 sides. Dozen is dozen is also interesting, right? Because this means I can have, for example, 1 dozen of donuts, right? 1 dozen donuts, okay? So this in particular means 12 because I said the word dozen, and then obviously donuts, okay? If I am talking about 1 dozen of roses, right? We go there to the store and we buy 1 dozen roses, okay? The lady will give us 12 roses, okay? So in the same way, if we go and we buy 1 mole, okay, of roses, okay, the chemist lady will give us 6.022 times 10 to the 23rd roses, okay? So when I use the word mole, I'm referring of this many items, okay? So let's go, okay? So moles, we defined it. So also I can say that if I have this container, okay, and I represent, for example, this container as the, for example, the Dunkin' Donut box, okay, this container I know will contain, so this is 1 container, okay, and contains, if really I put in there 12 donuts, okay, then I can say that the container is 1 mole of donuts, okay, or is a container for, I'm sorry, not 1 mole. So this is a container for 1 dozen, right? So the container will contain 1 dozen, okay, which means 12 donuts. So in the same way, I can have another box, okay, and now I say instead that this one is 1 mole, okay, so this one will be 1 dozen, containing 1 dozen. This box instead will contain 1 mole, okay, of molecules, for example. So 1 mole, okay, contain, maybe like that, I don't know if the E goes there, contains 6.022 times 10 to the 23rd items could be molecules if I'm referring to the total, if my items are molecules, or it could be 6.022 times 10 to the 23rd atoms if I'm talking about items that are atoms. Or I could be talking about any other thing, but this number is always the same. 1 mole of students will be 6.022 10 to the 23rd students. Now, also, this number 6.022 times 10 to the 23rd, okay, it's a huge number. If I take the decimal point and I move it 1 point only, right, this will be 60.22. But this number now is 10 to the 22nd. So this 23 means how many spaces I am moving the decimal point, okay, toward the right. So if I move it one more space, I have 602.2, but now this is 21 places left to move the decimal point to, right? Or this could be 6,022 times 10 to the 20 spaces, right? I'm moving this one here. So now the decimal point here, so I have 20 more spaces to go. So this means if I don't want to write times 10 to the 23rd, this number will be 6022, and we said 20 more spaces. This decimal point that right now is here has to be moved. So this means basically I have to add, okay, the spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this many moles, this many items, okay, are contained in 1 mole, okay? So as you notice, I will never, okay, count all those zeros. So unless you write this abbreviation, okay, times 10 to the 23rd, I am not going to count those zeros there, okay? Also, watch out because your calculator, okay, needs to read, okay, 6.022 instead of writing times 10 to the 23rd. So instead of writing this, okay, you are not writing this, you're just writing 6.022 E23rd. This is what you have to see in your calculator on the display. So do not time this number times 10 to the 23rd, okay? You want to write E23rd because this number here, so when you write 6.022, you're not doing this number times 10 to the 23rd. This is not what this means. When you write a number like this, this is just another way for writing this. Okay, so this is just an abbreviation. And to be honest, if you remember significant figures, by writing this means that I'm taking only 4 significant figures, okay, into consideration. Because actually those zeros are not necessarily zeros, there are numbers there, but again, we will never move forward, you know, with more than 3 decimals, okay? So we will never work with more than 4 significant figures, but if you do, then you need to substitute these zeros, okay, with the right digits, okay? So again, this whole spiel is, I want you to know that when I say 1 mole, I mean this many items. And if you're writing this number into the calculator, you got to use this condition here. Now, if you are using the calculation that Miss Yergol, I think, gave you, okay, you will have, for example, your calculator has, okay, this is the display. You have a lot of things here. There has to be one key where under or up on the side there says EE. So we'll need to push, and this button here looks like an apostrophe, I think. So to activate this E, you got to push in your calculator second, and then this apostrophe thing, okay? When you do this, you will activate the EE and you will read this number like that. So again, you will write in your calculator 6.022. Then you will click right away second, okay, the apostrophe, and then 23rd. Okay, so this is second, is not and, second. So when you click 6.022 second apostrophe 23rd, you will see on the display this number here. And that's what we want, because this means 6.022 times 10 to the 23rd. Again, this is not an operation that you're doing. This means this. So also, what else? Oh my gosh, what else we need? So we were talking about grams. So obviously, when you have your scale, okay, and you put on top of the scale something, okay, this something has a weight, and you will read the number here. Now, the number that you read here is the number of grams, okay? So the mass, okay, of your item, of object, whatever it is, okay, is measured in grams. Okay, now how do we move, okay, from the concept of, for example, if I give you moles, okay, our main task right now is the following. We got to move from moles to grams. Now, what does this mean? So the meaning of this is the following. Let's say that I have, so this is the container, okay, and we said this one is 1 mole. Okay, so inside here there are a lot of items, right? And the number of items is 6.022 10 to the 23rd. So we know that 1 mole contains 6.022 10 to the 23rd items. Okay, also the other thing that you know is that this mole, okay, when you put it on the scale, okay, has a different weight. Now this makes sense, because if your items are 6.022 10 to the 23rd elephants, obviously you will have a ginormous weight. But if instead you have the same box, or the box that I labeled mole, okay, and I have inside 6.022 10 to the 23rd ants, right, the weight will be completely different. So this mole, okay, if I want to go from grams, for grams, is a certain number of grams. Okay, but still the mole will always contain this many items. Okay, this many items. But according to which items we are talking about, the grams are different. Okay, now if you take your periodic table and you see the square, okay, the square, and it says for example hydrogen, okay, the number that you read here on the bottom, okay, is the grams of the hydrogen. But from now on, instead of considering the square as a atom, okay, now I want you to consider this one, okay, as a box instead, okay, that we call it mole. So now I have 1 mole, for example, of hydrogen, okay. So how many grams will this be? Well, here it says 1, basically. So the mole of hydrogen will be 1 gram. Now, if I have instead the same box, okay, labeled mole, okay, and I have here instead carbon, okay, I will see the 1 mole of carbon, okay, when I read it, okay, or I put it on the scale, I will read 12 grams. Okay, so according to what we are talking about, the number of grams are different. So if I want to now convert, okay, so let's say now I have, for example, 2 moles, okay, of carbon, okay, how many grams would that be? So I want to know the number of grams. So what you need to do, obviously, is to know the weight of 1 mole, right? So I know that 1 mole of carbon has a weight of 12. So obviously 12 grams. So obviously 2 mole of carbon will have a weight of 24 grams. just like 3 moles of carbon will have a weight of 36 grams, and so forth. So the whole point is that sometimes I have, for example, 2.7, okay, moles of carbon. So how do I do this? How many grams would that be? So it's more than 24, it's less than 36, obviously, because the number is between 2 and 3, okay? But how do I calculate it? So this is what I want you to do. So we said 2.7 moles of carbon. So I want you to do the following. So right now with your friends, okay, are at this point, okay? So this is one fraction, okay? So 2.7 moles of carbon over 1. So this is just one holding place, okay? But then I got to convert this 2.7 moles of carbon into grams. So because I want grams, I will put grams there. This is what I want, okay? What I want always goes in this spot here. So I always have to take the initial fraction, okay? And I have to multiply it by a new fraction. This new fraction is the adjustment that you need, okay? Now this adjustment is what the periodic table gives you. So when you take your periodic table and you read the square, which now is a box because it's 1 whole mole, okay? You know that this mole of carbon has a weight of 12. So let's write it here. So we know that 1 mole of carbon has a weight of 12 grams. Okay, so at this point, you can multiply basically 2.7 times 12, okay? Because this means 2.7 over 1, so this is a fraction, times the other fraction, 12 grams over 1, okay? So you multiply 2.7 times 12, and the number goes right here. So this is the number of grams that this multiplication gives you. So this means that whatever number it is, 2.7 moles of carbons, I can convert it into this many grams, okay? Why do we need to do that? Well, because I can weigh only grams on the scale. I can now weigh moles, okay? I got to weigh grams, okay? So this is a way of converting moles to grams. So let's try again. Let's say that I have 1.63, okay, moles, okay, of iron, okay, and I want to know how many grams are there. So this is where you got to show this cross here, okay? Again, this means a parenthesis, this is times, and this is the other parenthesis, okay? So this is what I gave you. So this is the given. This is always a 1, just to hold the place for the fraction, okay? And then this instead, okay, is what the periodic table gives you. So this is the adjustment, okay, which is equal to what the periodic table gives you. Okay, now you look for the box for iron, right? So this is iron. You will read here the mass, which is 55.8, I think. Okay, this is one box only, so 1 mole, okay, shows here 55.8. So you will write that 1 mole is equal to 55.8. And at this point, you just do your thing, right? So again, this is this fraction multiplied by this fraction, which means 1.63 multiplied by 55.8. Because this is fraction, moles and moles go away, right? They cancel out. So the only unit remaining is grams. So what you're solving for is grams. Now, if instead of having moles, if I give you grams instead, let's say that I give you 164, okay, grams of iron, okay. This time I want to know how many moles is this, okay. So what you do, exactly the same fraction as before, okay, but now from grams you got to go to moles. So again, this is the given, this is what I want, okay? So, and this all I want, this whole fraction, okay, is your adjustment, okay? Which means whatever the periodic table is giving you. We are looking at iron, so you know the 1 mole of iron, okay, is the same as 55.8 grams. We just said that, right? Then you will go there and you will say 1 mole is 55.8 grams. So now you have this fraction multiplied by this fraction. So you have 164 times 1, right? So 164 times 1 divided by, so this is the same fraction line that we have here, 1 times 55.8, which is 55.8. Okay, so basically you got to divide, okay, 164 divided by 55.8, and that will give you, so this times 1 is just 165, and this will give you the number of moles. Okay, so in summarizing, okay, if I give you moles, okay, and I want grams, okay, so this is the number of moles that I gave you. Whatever number I have of moles, you do this fraction line, and then because this is your adjustment, okay, you will have the 1 mole is the same as the numbers of the periodic table that the periodic table tells you. So let me write here, 1 mole is the periodic table grams, okay, according to the particular element. So if you want to go from moles to grams, this is the setup, okay? You take this fraction, you multiply by this fraction. If instead I give you grams, okay, so the number of grams now I'm giving you, and I want the number of moles, okay, you will do still the cross, okay, which means still this fraction multiplied by this fraction. This is still the adjustment, okay, and this is 1 mole, so you got to flip this fraction here. 1 mole is a certain PT number of grams, okay? So this, if I want to go from moles to grams, this is if I want to go from grams to moles, okay? This is for it. I would suggest you to stop this one, okay, this video right here, and work the first, I want to say, and the second probably worksheet that we have done. Then I will post another video instead once you're familiar with this, okay, that allows you to move from grams to molecules. So not only we know how many grams are in 1 mole, okay, but also how many molecules in that case the mole contains, which in a different verbiage, right, means if I know that 1 donut has a weight of 50 grams, for example, right, I have, oops, so I have 50 grams of donut, okay, so this is 50 grams per donut, so for 1 donut, okay. If I want to know how many grams are, for example, 200 donuts, what would I do? So I will write 200 donuts, okay. I want to know how many grams, okay, in 200 donuts. So what do I do in this case if I want to show the fraction there? I will say that 200 donuts, okay, is how many donuts I know. But to find how many grams do 50 donuts weigh, I got to go to my adjustment, to the only thing I know, because I know the 50 grams is the weight of 1 donut, right? So obviously, I will take the 50 grams of 1 donut and I multiply by the number of donuts, right? So in this case, I will have the total grams. So I don't know, but technically this thing that seems so complicated is really super easy when you talk about donuts or pencils or whatever. But as soon as I, for some reason, gives you compound, all of a sudden, I want to say you guys just freak out. This is what my experience teaches me. So it's easy, okay? So relax and just work on converting right now what we said before, moles and grams, grams and moles. Good luck, and I'll see you soon.